Welcome. In this video, we're going to walk through the basics of using EnzymeAD to automatically differentiate C code. We'll download and build Enzyme, write a simple polynomial function, and see how Enzyme generates its derivatives at compile time. By the end, you'll know exactly what you need to set up your toolchain on Linux and start experimenting with EnzymeAD yourself. So let's get started. First, we're going to install Enzyme using Homebrew, which is a package manager that was originally for Mac OS, but also works with Linux. And Homebrew makes installing Enzyme incredibly easy. All we have to do is first run this installation command to install Homebrew. And once we've installed Homebrew, simply write brew install Enzyme. And Brew will install all of the dependencies that you need. After Enzyme has finished downloading, we want to make a new project directory and open a main file. The function that will differentiate is a polynomial that takes in a value x and returns x times x plus 2 times x plus 1. So if we call this function, poly with some value, say x equals to f of, or this is just standard syntax for printing, format printing in C. And we should be able to just see the result on the screen. Let's zoom in a little bit. Okay, so let's try making this using Clang. We're going to take in main.c and produce a main file. If we run main, you can see the value of x is equal to 2.464900. And that's not quite true. Actually, it's the value of the poly of x that's that. We try one more time. There we go. The poly of x is equal to 2.464900. Great. So let's differentiate this function. How do we do it? Well, we first want to forward declare or prototype the enzyme AutoDiff function. And this function takes in a number of different possible sets of arguments. First, the return value needs to match the return value of the function that we're differentiating. In this case, it's double. And the input argument should also match. But we also have to pass a void pointer at the very beginning as the first argument. And this is our function pointer, the pointer to the function that we want to differentiate. So now we're all set up. We can run this differentiable program and calculate the gradient. So let's do that. Gradient is equal to enzyme AutoDiff. We'll pass in the poly function and the value of x, which I'm going to pull out here, so that we don't repeat ourselves. And we're getting an error of just a semicolon and saying that this is unused. So let's print it. We're also going to print, what is this? D poly dx is equal to this value of grad. Printf. Alright, hopefully this makes sense so far. So all we did was we forward declared enzyme AutoDiff with the void star pointer for the function that we want to differentiate and the argument that it takes in and its return value. We then called that function enzyme AutoDiff on the function we want to differentiate, poly, and the input argument x, and return it into a variable called grad. We then print it. Now if we try to run or compile this, we're going to get an error because enzyme AutoDiff is not defined. And this is where Enzyme is a slightly different than other libraries, where in other libraries you might link using something like, for instance, like if you wanted to link, I believe, ALSA, you would run -l a sound with this flag to link a library. But because EnzymeAD operates at the level of LLVM, that means that we have to connect it as a compiler pass. So what we want to do is list the installation location of Enzyme using the brute info command. And if we list this directory, we can see the lib subdirectory. And if we list the subdirectory, we can see the plugin Clang enzyme-21.so. And the command that we want to run to compile our program is clang-f-plugin, which hooks in the library as a compiler pass. And then we run with the main program, and we can see that we have the gradient of the polynomial with respect to x is equal to 3.14. To double check, we can symbolically differentiate this function. dpoly dx is equal to 2 times x plus 2. And if we plug in 0.57 for x, that becomes 1.14 plus 2 is equal to 3.14. We have, in fact, differentiated a polynomial with respect to its input arguments in C using an LLVM compiler pass. Alright, I hope you enjoyed this video. Stick around for the next one.